So, this video is going to be all about the time complexity of bubble sort. Now, the time complexity of bubble sort depends on the arrangement of elements. The time complexity, its best time complexity, its worst case time complexity, and its average case time complexity depends on the arrangement of elements, that how the ordering of element is in the input of the list. Worst case is when the array is in descending order. For example, this is the input 5, 4, 3, 2, 1, and in this case the array is in descending order. Why is it worst case? Is that worst case means that when the algorithm is taking more time than any of the cases, then it becomes worst case. So in worst case, what happens? Worst case, we can have the input list as 5, 4, 3, 2, 1, where the bubble sort is based on having number of passes. Like in first pass, it will do the comparison and swap the elements, and then it will have second pass and it will do some certain number of comparison, and it will swap the elements, and then give us the sorted list having some certain number of passes. So in worst case, if we have this input, this is the worst case input where the time taken can be more, because when the input is in descending order, then there will be comparison, there will be comparison, and there will be swapping, like swapping of the elements in each comparison. After each comparison there will be swapping. If the array is in descending order, then after each of the comparison we'll have the swapping of the element. That is why it is taking time, because if there are more number of swap, then more number of time will be taken. That's why worst case is when the array is in descending order. For example, 5 and 4 will be compared. 5 is greater, so 5 should come at the end, right? So 5 is greater, then you need to swap it. And then 5 and 3 will be compared. Now because 5 and 4 is swapped, so 4 in the place, consider that in the place of 4 there is 5, so 5 and 3 will be compared, and then 3 and 5 and 3 will be swapped, and in this way 5 will come to the end, and the array will be divided into two parts. One will having 5 and the another rest of the elements, and 5 will be considered as sorted. So this is the way how bubble sort works, but I'm telling you that this is worst case, because this in each of the comparison it is going to take it is going to swap the values in each of the comparison. After each of the comparison there will be swapping of the values. But the best case is when the array is already sorted, like when the array is 1, 2, 3, 4, then in only one pass, at least one pass is like in required, because how is the algorithm going to know that if the array is sorted or not? For that it is going to take one pass at least. That's why best case is when the array is already sorted and we need only one pass. After one pass the algorithm will know that this input is sorted, so we don't need more number of passes. So this is the best case, and there will be no swapping of the element. If the array is already sorted, then we don't need any, there will be no single swap. Okay, and if even there is a single swap, then there will be more passes. So to ensure that there is no more pass, the element should be sorted, and if there is no swapping of element, then it will not take more time. Okay, and worst case, okay, average case is when there are like the positioning of element is in this way, like where 1, 4 and 5 are sorted, like it is at its correct position, but 3 and 2 is not at its correct position. So this is the average case, because in each of the comparison it is not necessary that there will be swapping. See here, 4 and 5 is sorted, so 1, 3, 2 only needs to be not 1, 3 and 2 only needs to be swapped, right? Average case is much closer to the worst case, because it is also going to take same number of time, because in average case also there will be some number of swaps, and there will be some elements which will be fixed, so there will be no swap for them, but that is closer to the worst case. Now this is the code of the bubble sort, and this is the standard bubble sort, where we have two loops here, and the first loop is running till I is when I is less than n, starting from 0. N less than n means n minus 1. So this one is taking n minus 1 time, and this one will also be taking n minus 1 time. So if the, like in the best case, when this is the input, then it will enter to the loop, and then comparison, this is for comparison, will be done, and the time becomes n minus 1 into n minus 1, that is nothing but order of n square. When the input is 5, 4, 3, 2, 1, then also the same thing will be done. like each of the time we are entering to this loop and we are swapping the values, okay. So this will be taking some time, okay. And if this is not lesser, then for example, if we take best case, then this is not lesser, right? So if this is lesser, then you have to swap it, and if this is not lesser, then you don't have to swap it. So in this case 1 and 2, so 1 is lesser, okay. And 2 is like is 2 is 1 greater than 2. Condition is like, is 1 greater than 2? No, 1 is not greater than 2. Then you just compare 2 and 3. So this is like that, okay. And there will be more number of passes in this case, because we are checking for each of the values here, we are not stopping anywhere. So there will be more number of passes here also, and it will have more number of comparison, and it will take more number of time, that is order of n square, even in best case, okay. And the same is going to be the case in worst case. It doesn't depends on what is the input array, like the standard bubble sort is, it doesn't care about the arrangement or the ordering of the input values, like what is the input, it doesn't depend on that. The time complexity is order of n square in each and every cases, because this is overall taking n minus 1, this is also taking n minus 1, it becomes order of n square. So in this way, this standard bubble sort takes order of n square in best case, average case, and in worst case. Now we can improve this time complexity. The time complexity can be improved by taking flag value. What happened later, previously what we were doing is that we were having even if we know that this in the best case we knew that this is sorted, so we don't need more passes, but still we were going inside this loop and we were checking for the another elements. But when the improved, if we are considering this improved bubble sort, then we will set the flag value as 1. When flag value will be 1, we will enter this loop and we'll check if the condition is satisfied or not. If the condition is satisfied, then we are not going to change the value of flag. For example, if the input value is 1 2 3 4 5, then 1 is compared to 2. Is 1 greater than 2? No. Then you don't set flag as 0. Flag will be remain 1, and we will come outside of this loop, and flag, if flag is 1, then break. Then you come out, and you don't need to compare in the next pass, okay. So you'll have only one pass. So this is how we set flag value, and we reduce the time complexity from order of n square to n in case of best case, okay. In case of best case, we improve this time complexity. Otherwise the number of comparison is going to be same for the when the arrangement is in descending order, because in that case, in worst case, in every comparison, after every comparison we are going to swap the values. So that is definitely going to take some time. That is going to be same as the time complexity that was taken by the standard bubble sort in worst case, and in average case both are going to be same, but only the time complexity is going to be improved in the case of best case, because we are taking here flag value. When there is swapping of the values, let's say we have value like this 1 3 2 4 5, let's say 3 and 2 here will be swapped, right? So if this is swapped, then flag value will be set to 0. Now the flag value is set to 0, so flag is not equals to 1, so we cannot break, we will again start this loop. So in this way we'll have next pass also. But when the array is like 1 2 3 4 5, then there will be no swapping, then the flag will be 1. If flag is 1, then we are going to break, like we are coming out from the loop, and will not have any more passes, because the algorithm will know that this is the sorted list. That's why we don't need more time, like more passes to waste time on. So we are not going to waste time on that. So that's how bubble sort algorithm works. Like the worst case, I already told you, that depends on the arrangement. Like if it is in descending order, so the first pass goes like it have 4 number of comparison. In the second pass it has in the first pass it has 4 number of comparison, and the value of the elements are 5 4 3 2 1, that is 5. So number of comparison is 4, so n minus 1, isn't it? Because n is equals to 5 here, then number of comparison is 4, so n minus 1, it is n minus 1, right? So here first pass is taking n minus 1, second pass is 3, that is 5 minus 3, that is 2. It means that this is n minus 2. So in third pass it is taking n minus 3, in fourth pass it is taking n minus 4. So in this way the sequence becomes like n minus 1 plus n minus 2 plus n minus 3, in this way. So total number of comparison, if we add, this is the for mathematical formula, if we write it in, then we'll get sum as n into n minus 1 by 2. and this becomes order of n square. So this is how we get order of n square. And for average case also it is going to be same, because the average case input forms like let's say 1 3 1 3 2 4 5, where 1 4 and 5 are fixed, like it is at its correct relative position. Only 3 and 2 is not at its correct position. So in that case also the same time will be taking, this is going to be the same number, like the average in average case it is going to be same. Okay, when we talk about we talk about the best case, then there was a flag value in improved bubble case. In improved bubble shot, there was a flag value set to 1. So we will compare 1 2 2 3 3 4 4 5, and then will come out, and then we'll see that flag is equals to 1. So when the flag is equals to 1, then we don't have to iterate again, we don't have to see again and do the another pass. But if the flag value is 0, when is going to be the flag value 0? When there is a swapping of the element. If there is a swapping of the element, then flag value is going to be 0. And if the flag value is not equals to 1, then we don't break it, we just start again and iterate it again. But if the flag value is equals to 1, it means that the input is already sorted. And if the input is already sorted, you don't need another pass. And when you don't need another pass, it means that you are not taking more time. Okay, so that's why the time complexity is improved here. And when there are 5 number of elements, then we have 4 total number of comparison, so that is n minus 1 comparison, and n minus 1 resembles to order of n. So that's how best case is improved from order of n square to n by using improved bubble shot. In place of using standard bubble shot, you have to use the optimized version of this bubble shot, which is known as the improved bubble shot. So this is how the time complexity is optimized. So I hope that it has helped you. Thank you very much.